A quick little run through working with a class in Python. So to build on our combo menu app, I've created a class called food order, and this diagram is called a UML diagram, and it shows the name of the class. The class is called food order. Then it shows for each instance of the class the attributes that each object or instance of the class could have. So each instance is going to have an order number, which is an integer, sandwich, which is a string, a drink is a string, fries are a string, ketchup's an integer, and total price is going to be a float. And all of these are things that we worked with when we created lists of orders, but now we're going to create the order as an entire object, as an instance in a class. Some of the things we can do to an object that's an instance of the class food order is we can change the sandwich. We send it one argument called sandwich, that's going to be a string. We can change the drink. Same thing, one argument called drink, it's a string. Change fries, that's also a string. Our ketchup is actually going to be an integer that we'll send, and we can change the number of ketchup packets by sending an argument called ketchup that's an integer. So this diagram shows all of the things that each order will have as attributes, and then also the functional attributes that we can do, things that we can modify in an instance of the class. Over here is the Python code that actually creates the class. So we use the word class to define a class. We say, hey, we're going to make a class. It's going to be called food order. Here are the following things that are going to be included in the class. First of all, we have a variable called ordnum. I'm going to use that to create each order number, bumping up by 1 each time an order is made. The init function, underscore init underscore, is kind of the initialization for an instance of the class. So this creates an object in the class food order. And the self is going to be just the name of the object we're creating. We don't actually send that or pass that as an argument. These last arguments, though, they do get passed along. Sandwich name is a string that we'll send to assign to the object. Drink size, again, another string that we will send. Fries size, another string we'll send along to the argument or pass along to the class definition. Ketchup, and then total. So these are all the arguments we send along. And then down here under the function or the definition for the initialization function, indented to indicate that it goes with this function up here, are the attributes and which of these arguments here will be used to create the attributes. So for example, self is just the name of the object we're creating. The attribute order number, which over here we see is an integer, is just going to be assigned by taking this object or variable ordnum from the class food order. So it's going to start out as order number 1. The attribute sandwich, for whatever the name is of the object we're creating, will be the argument sandwich name. So this argument that's passed along when we call the initialization function will be assigned to the attribute sandwich for that object. This argument drink SZ will be assigned to the attribute drink for the object we're creating, and so on. Down here, total price is the argument TOT that is sent along or passed along when we create the instance, and I multiply it by 1 with a period. So think about why do I multiply whatever argument I send by a 1 period. And I'd suggest you go back here to take a look at the class definition and see what type of data we expect in total price. And then finally, when I'm done creating the first instance of an object, or any instance as an object, I take the variable ordnum in the class food order. So this is class name dot variable name, and then I increment it by 1. Basically saying new value of ordnum is old value plus 1. So that is how we'll create an instance of the class food order. Down here is another program I've created, another script I've created. I am importing the class food order from the file name GiesemanR314 food order class example. So this file is called make food order instances. And this file up here where I've defined the class is called GiesemanR314 food order class example. So this name of the file must match the file name in which we've defined the class. The only thing we don't do is we don't bring the .py along. We just use the file name. And then we say, all right, this is the class I'm going to bring in. So I've imported it. It's available for use. And anytime I want to use the class, I just refer to it by name. Its name is food order, capital F, capital O. It's very important that you use the right capitalization. And I'm going to create an object called first order. I'm going to assign it the result of calling the food order class, specifically the initialization function up here. And I'm going to pass it the following arguments. I'm passing it the string beef. That's going to be assigned to the value sandwich name up here. Sending it the string large, that's going to be assigned to the argument drink size. The string small, that's going to be assigned to the argument fry size. The integer 3, which is going to be assigned to catch, and the integer 4, which is going to be assigned to tote. So as I create the object first order, this initialization function takes on the following. The self variable is temporarily assigned the value of first order. So we replace all of these times that self shows up with the name of the object we're creating first order. That means I've created an object first order, and first order.order number, an attribute, is equal to whatever the value of order number was. Well, the first time through it's 1, and so on and so forth. Well, when I go and print first order, I would expect to see all of this information, agreed? So let's go and run it and see exactly what we get. We get an error. Perfect. Like I said, it's important to capitalize, and I intentionally did this to show you there is no such thing as food order with a lowercase f. It has to be capital F. So let's go ahead, save our file, come down here, run this again. And again, capitalization is important. That one I did not do on purpose. That was a mistake. Let's save our file. Let's run this again. And when we print it, we get this cryptic message. We said print first order, and sure enough, this prints first order. Well, first order is an instance of the class food order from the file Geeseman R food order class example, which is this file up here. And this is just a memory location. We don't know what that means through data abstraction. We're not really sure. We don't really care. However, it didn't print any information. It just printed out that it's an instance of the class food order, which is nice to know and all, but we'd really like to see the information. So one of the things we can do when we define a class is we can also define, in addition to the initialization function for an instance of the class, we can also define a string function. And I'm going to get rid of these multi-line quotes here and turn this into actual code. And the string function doesn't receive any arguments other than the object name that we're printing. So in this case, we're going to say, let's print first order. And because it's an object of the class first order, when we print it, it looks for a string function. And the string function says, here's the string to print out. Instead of saying it's an instance of this class, it's actually going to print information. And the self is going to be replaced with the name of the object first order. So as we go through, I decided to create a string that will be returned or sent back as a value to where it was called. And I'm going to do it by concatenating additional information. So the first thing I do in the print string is I say, let's concatenate the string order number with the string function receiving the argument self.order number. Well, because this object was called first order, this becomes first order.order number. And concatenate that with the string includes in a new line. Then I'm going to add to the print string a tab. I'm going to run the string function on the first order.sandwich attribute. So whatever the attribute value is for that will be returned as a string, and concatenate that with the word sandwich, another new line. Tab, whatever the attribute for fries is for this object, turn it into a string, concatenate with fries, and so on. So we should get 1, 2, 3, 4, 5, 6 lines of output for each object. Well, in this case, we only have one object. Return means to send this value back to where it was called. We're calling it in the print line down here. And we're going to return whatever the value of the variable print string is. And up here we see print string is nothing more than a whole bunch of concatenated strings. So now let's come down here. Let's file save to make sure that our multi-line quote's going on. Now this is an actual function. Let's come down here and run this again. Now printing first order, which before just returned an instance of the class. Now let's see what it looks like when we've defined a string function in our class. And sure enough, scroll up here, it says order number 1 includes a beef sandwich, small fries, large drink, 3 ketchup packets, which cost $4.0. Beef we sent along as the sandwich name. Large we sent along as, well, what's the second argument? Drink size, and sure enough, large drink. Small we sent along as third argument. 1, 2, 3 is the fries, small fries. We sent along an integer 3 to match ketchup packets. And we sent along a 4 for TOT. TOT is assigned to the total price attribute for this object. And sure enough, it says down here 4. And you now see why I put a 1 period up here, so that in case we do send an integer, this forces it to be a float. So we actually get cents in addition to dollars. I bumped up the value of order number by 1 at the end, but I never used it again because I didn't create a second object. So why don't we come down here and let's create a second order. Let's say that's going to be equal to calling the class food order, specifically the initialization function. Let's get a chicken sandwich. Let's get a small, what's the second argument is small drink. Third argument is fries. Let's get a large fries. Let's order 7 ketchup packets, and let's say this is $12.30. In addition to printing first order, I'm also going to print second order. Let's run this now and see. And here we go. Order 1 includes that. Order 2 includes that. And again, the 2 only bumped up to 2 because we used a variable to do that. I didn't send that as an argument. And as I continue to send more instances of the class, it would continue to bump up the order number. So now I have 2 objects, which are instances of the class food order, and they have the attributes that I sent. Well, let's say that I want to change first order sandwich to tofu instead of beef. Well, one of the things I can do is after I've created it, and you saw that when I created it with this line up here, it has a beef sandwich. I can come down here, I can say, hey, let's take first order and change its sandwich attribute. So it's object name dot attribute. Let's make that equal to tofu now. And let's now run this. So it's going to print first order only after I've changed the sandwich. So in this case, no longer will it print beef sandwich. It should print tofu sandwich. Let's do a file save just to make sure. Let's run it. And sure enough, order 1 now includes a tofu sandwich. So no longer do we get constrained by the original attributes or arguments we sent. We can change individual attributes. What if I just want to print out the sandwich for each one of these? Well, I can say print first order.sandwich and print second order.sandwich. Let's do a file save. Let's run that. And sure enough, it's just tofu and chicken. Well, let's say that I want a line separator. Because up here in the string definition, I included line separators, this comma down here didn't put them on the same line. Why don't I just concatenate this with a new line string, do a file save. Now let's run this. And sure enough, it prints out just the sandwich attribute from each of my 2 objects. Well, why don't we do this? Why don't we create now, instead of just having objects, sitting by themselves, why don't I create a list? Let's call it order list. Let's initiate it as an empty list. And down here, we'll still change tofu. But down here, I want to say order list dot append first order, and then order list dot append second order. And then down here, instead of printing out that information, let's print out order list and see what we get. Do a file save. Let's do a run. And now when we print the list, that's interesting. It just prints it with individual instances of the class. So we now see that if we print out a whole list of objects, it's not going to print out the string, it prints out the actual object. What if I were to do this? What if I said print order list just index 0, which would be first order? Now it goes and it prints out the string result. So if I want to print out all of the items, why don't we do this? Let's create a for loop. Let's indent it so it goes with the for. And what I want to print out is each thing. So this variable, each thing, is being assigned just in the for loop, and it's going to take on the values of each of the things in order list one at a time, and then do with it whatever I have indented after the for loop. So in this case, all I'm doing is saying, hey, create a variable called each thing, take each item in the order list one at a time, and print it. If I run this function now, or this script now, well, there we go. It prints out order 1 and order 2. Same exact thing we had before, but now we're using a list and a for loop to walk through it. Much more efficient. The nice thing about that is, what if I create a third object? So this third order, I'm going to then also append. And now when I run it, sure enough, we get order 1, order 2, and order 3. So the nice thing about the for loop is no matter how long my list is, this will accommodate all of those items. Another trick I can do is, instead of creating an object up here and then appending it to the list, I could also directly do this. So I haven't created a new object in my script down here. All I've done is I've created a new instance of the class and directly added it to the list. So it still exists as a class instance. It just hasn't been assigned to an object. All it's going to exist as is 1, 2, 3, the fourth element in the list order list. So it's going to be index 3 in there. I can address it individually. I can down here, I can say that would print out this last thing here. I can change things about it. I can say, instead of chicken, let's make this sausage sandwich. So let's say order list index 3 dot sandwich equals. So now I'm directly accessing the object in the order list. I'm changing the attribute sandwich for it. And if I run this now, sure enough, order 4 says, hey, it's a sausage sandwich. So just some things you can do with classes. Quick introduction, but it should be all you need to know to work with the the classes in the registration activity for 314. Good luck. Continue on.